Good morning. So first of all, I want to thanks for the invitation, and also want to acknowledge my co-presenter, Engrg, and also Tinzhu Zhu from International Food Policy Research Institute. So there are a lot of interest on drought, and particularly we look at how climate change might affect the drought in the future. And we also look at how climate change or variability might already affect the drought in the past. So in the literature, there is some obviously inconsistent assessment, like including the Sheriff paper from Princeton and also Dr. Dai's study. And AR5 recently has had a major update about the impact of climate change on drought. And basically they found there is not enough evidence available in favor of or against any global trend in drought. And they also admit the global increase in trend in drought suggested by AR4 was probably overestimated. So those are the issues. So we have many indicators to describe drought. So for a given indicator, and also a time series of that indicator. So we have a quite complex system. So we could, so this time series has multiple characteristics. So for example, the intensity, so that is the maximum absolute value of a drought index below this critical level. And we also have the severity, that's basically represented by this shaded area. The duration is an index, is continually below this, the time period continually below the critical period. And we also can identify the inter-arrival time, that is the time range between the initial time of two consequent drought events. Now, the question, given these multiple characteristics, we have a set of questions. So how is each of these characteristics change? How does each of these characteristics change with time? Are there any trends or abrupt changes with time? So how will climate change affect these characteristics individually and jointly? So how are the those characteristics correlated? And then how do these characteristics vary spatially? And finally, for impact assessment, which characters mostly affect a particular system, like hydrology or agriculture? So is the intensity or severity or the duration the kind of major factor or not? So we try to use some sites in the US and India to address these questions. So we define the drought return period based on some individual characteristics and also some multiple characteristics. So for multiple characteristics, we have to consider about the correlation. And so here we use as usual, we use a Copless multi-variable distribution to describe that. This diagram actually is borrowed from a private study. So this shows a typical return period based on correlated duration and the intensity. So we could define return periods based on individual characteristics like severity, duration, and intensity. That is based on the expected inter-arrival time. And we use the Copless-based joint distribution. We could define the return periods based on some joint characteristics. Like here we consider the correlation between duration and intensity, then we could calculate the return periods based on the joint intensity and duration. So we use two data sets. So one of the purpose is to compile, to find some consistency or inconsistency from different studies. And we use Dr. Dai's study that actually we have he provided the data from the past 100 years. And we also have the projections from AR4 and AR5. And also we use the data from Princeton. So with different time, actually only recent 50 years, and you can see that the spatial resolution of these two data sets are different. Okay, so as I said, our original purpose is to assess the drought conditions in the US and India. So far we have only done some sites in these two countries for some comparative studies. One thing we want to do is to look at how these individual characteristics, like duration, severity, intensity, and the interval time, how each of these characteristics change over time. And we want to identify the trend, and we also want to identify some abrupt changes. So, I mean, just by looking at this curve, looking at this plot, we can only find out there is a kind of slight decline of the intensity during the past 100 years. For this, this is for one site in Missouri. Okay, so now we plot this, as I said, we're going to look at these individual characteristics, and these curves compare the three severity, intensity, duration over two time periods, 250-year time periods from 1999 to 1954, and recent 50 years, and also the projections from AR4 and AR5. So for this particular site, you can say that actually for the severity, if we look at the past 100 years, there is a quite big difference between the severity from the two time periods. And if we look at the feature, if projected by AR4 and AR5, actually the intensity will become less serious. So that means for the given return period, the severity will decline. And that's probably mainly caused by the duration. So although the intensity might increase, but the duration will decline. Combine these two together, we might have reduced the severity. But this is a result for one site. Okay? And then we compare that to 8 sites in northern India. And so basically we found there is only 2 sites. Site 1 and site 8, they have shorter and less severe drought events after 1955. And the other sites, the drought events appeared with increased length and severity. And also, we compare these two data sets. So with this green represents the results based on DICE data, and from Sheriff, this is red. So I can see that for duration, for this 8 sites in India, for duration, these two data sets produce similar results. But for severity and the intensity, they match pretty well with shorter drought. Well, I mean, with more frequent drought, like when the return period is small. But when the return period is large, like for 100 years, there are quite much difference for severity and intensity. Okay. So then we also, I just showed you the individual characteristics, and we also do that for the bivariate joint return period. So this is for, so these two plots compare the joint distribution with, so these numbers here are return periods, okay, from 5, 15, 25, and this is duration, this is intensity. And for this early period and later period. So comparing this, we found actually for the same frequency represented by the return period, drought with the same level of intensity had shorter duration in recent 50 years than early 50 years. Sorry, there is a bit problem here. We also compare this projections from AR4 and AR5. The results, the basic results is for the same frequency, more intensive drought might occur. That means the intensity might be higher, but the duration might be shorter in the future century. And AR5 projects much less severe condition than AR4. Okay, so then we have the similar comparisons for the 4 sites in the US. I will just go a little faster with these results. So again, this is to compare the 2 data sets. It's a similar results as the sites in India. So basically, for short return period, the results match well, but for large return periods, there is some quite big difference. And again, for the India sites, they match quite well for the duration, but for the US side, we can also say some difference with the duration characteristics. Okay, and this is for the joint the biovariable joint return periods. So based on this, some incomplete study for some sites in these 2 countries, we have some preliminary summary about the results. So first, the drought characteristics such as severity, intensity, and duration, they show a different frequency in the past century at some sites in India and the US. And then the frequency change over time with significant shifts at some sites. So based on the projections from AR4 and AR5, we found the drought in the future can be more serious in some aspects, but not necessarily all. Then the frequency vary over space with substantial differences over size even in the same region. And this is our purpose to do the study in India. So 8 sites, actually, they are located in the same region, in northern India. But even for this nearby size, the difference are quite substantial. And also we found the preliminary analysis showed the severity and duration are correlated, and the bivariate joint return periods can be successfully identified by coordinate distribution. And the ongoing studies include, so currently we only analyze the difference in 250 time period. And with more data, we hope we could define and explore some dynamic return periods based on multi-variable correlation. And particularly, we want to understand which drought characteristics most affect the natural and human systems, such as hydrology and agriculture. I will stop here. Thank you.
Any question for Shiming?
Yes, please. All right, go first. Actually, we have done the kind of retrospective analysis for the past century, and there is no issue for that. But for the future projections, like the projections from AR4 and AR5, this is certainly an issue, but we have not addressed that yet. Okay. Yeah. Rich.
Very nice talk.
Thank you.
What do you speculate about why the AR4, AR5 simulation led to such severe differences in the magnitude and intensity of the drought? They showed much less severity.
Okay. That's a very big question. I'm not really a scientist on that aspect. Okay, so probably someone can help. But my thinking is that because during the past 4 or 5 years, there are so many studies, there's so many interest on this issue, and many of those studies they got inconsistent results, and that probably some way suggests IPCC to relook at the problem. And actually, what they said is there is not enough evidence to against or to support any of the trends. So that's a current issue. That also means more research is needed in the future. Okay.
Great.
All right. Thank you so much. Okay, thank you.